Welcome back to Frequency Online Math. So today we'll be talking about normal distribution. You know that this normal distribution is types of what? Continuous what? Random variable. So this normal distribution is defined on the normal distribution is defined as the probability density function. What is the probability density function? I told you that under continuous random variable that is associated with PDF, whereas this strict is associated with what? PMF, probability mass function. So this probability density function in the curve is called our what? F of x. So our f of x is known as the PDF. For the continuous random variable, say x. So our continuous random variable is what? X. So you know that x can take any value. It can be 2, it can be 2.1, 2.5, 3.7, 3.5, 3. Any value. X can what? Take what? Any value. You know, if you are measuring a height, you have you see where all these things are coming from. If you have a height, you want to measure height, it can be that your height is about 2.8 meters or something like that. So this is our continuous random variable, say what? X. Now in the system, this is our system. So for a random variable x with mean mu and standard deviation sigma, the probability density function for the normal distribution is given by, so our f of x is what? 1 all over square root of what? 2 pi, then times sigma what? Squared. Then exponential minus x, that's the random variable, minus mu, that's the mean, squared, all over 2 times the standard, the variance. 2 times what? The variance. So let me take it again. That's 1 all over square root of 2 pi, then standard what? Deviation squared. Are you seeing it? Then exponential minus x minus what? The mean squared all over 2 times what? The standard deviation. So this is the formula. Hope you can see it now. So this is the formula. So let me still clean it. So you can memorize it because you'll be using it to solve questions. So where this is our mean, mu is what? Our mean. Then this sigma is what? Our standard deviation. And this variance is sigma squared. Then our x is normal random variable. So in this normal random variable, we have something like a bell shape, like this. We have something like what? A bell shape. Now, the bell shape, this f of x is called the PDF, right? And suppose we have points here, A, B, C, D, E. So this normal distribution is just trying to tell us that the area under this curve, this whole place, the area under this whole place is equals to what? 1. That the total area must give us what? 1. That's what it's trying to tell us, this normal distribution. The total area, if you want to find the area under this thing, that it must be equals to what? 1. That's the total area. Now, it's also trying to tell us that our f of x must be greater than or equals to what? 0. So our f of x must be greater than or equals to what? 0. So this curve must be greater than or equals to 0. You cannot see this curve to be less than what? 0. It will what? Go down. No. It must be what? Greater than or equals to what? 0. As you can see, this is our origin. We started from here. Greater than or equals to what? 0. So we cannot see the curve going like this downwards. Now, another thing I want to tell you is that, for example, if I want to find that my f of x, if I want to find that my f of x, sorry, if I want to find the probability that x is what? Less than a. So probability that x is less than a, this is the point, right? This is my a. Probability that my x is what? Less than a will be what? This place, the area under this place. Are you seeing it? So that's the probability that my x is less than a. Now if I want to find the probability that x is between what? B and what? C. If I want to find the probability that my x is between what B and C, it will be where? Here, these are B, and where? Here. The area under these two things, these two points are what? Is the probability. The area under these two curve is my what? Probability that my x is what? In between B and what? C. Are you there? Now I want to tell you another thing, that this thing can also be written as probability that it can also be written as probability that B is less than or equals to X and B is less than or equals to what? C. You understand? It can be written like that. So if you see something like B is less than X is less than C, it still means the same thing as this. Are you there? Now, if you, for example, if you want to find the probability that X is equals to E, see E here, probability that my X is equals to E. As you can see, X does not have what? Range. Are you there? It does not have what? Range. So what you are going to have is what? It only have what? Height. So probability that X is equals to E is equals to what? 0. So that's what I want you to take in mind. For example, they ask you find the probability that my probability that X is equals to D. What will it be? It will be what? 0. So that's what I want you to put in your mind. So whenever you see these things, probability that B is less than or equals to less than X is less than C, it simply means this also. Are you there? Now, we have that this f of x describes what? The height. The height from these 2 points. This f of x tells us the distance from this continuous random variable to this what place. This, let's assume here is what? X. It tells us the distance between this x and this point here. You can call this point P. That's the maximum height here. You can call it P. This f of x tells us what? The distance between these 2 points. So in our next video, we'll be solving examples on this normal distribution. Normal distribution. It's also called Gaussian distribution, I think. So thank you for watching and may God bless you. Bye bye.